Good morning, everyone, or good afternoon, depending on where you're attending this webinar from. Firstly, I would like to thank you all for taking time out from your schedules to attend this webinar. Welcome again. Today's topic is securing your medium voltage substations with secure gateways. Through the webinar, we wish to provide insights on how NERC CIP or IEEE 1686 guidelines and various security requirements as per the IEC 62351 are met. We would introduce our latest SYNC2000-M5 Secure gateway and use this product as an example to explain how to secure substations. To introduce myself, I'm Gautam, and I take care of Europe and Latin America business for Kalkitech ASC offerings. ASC being the US-based company acquired by Kalkitech in 2014-15. A brief on Kalkitech. Kalkitech has long been an advocate of open standards and standards-based communication to facilitate interoperability in the true sense. Our solutions enable customers implement mission-critical applications across the smart grid solution spectrum, ranging from substation automation to wide area monitoring, distribution automation to advanced metering infrastructure. A few points to keep in mind before we start off. Since we have a large number of participants, this is a listen-only webinar. However, to facilitate clearing of your doubts or queries that may arise during the course of the webinar, you can kindly send us your questions by typing in the window provided during the talk itself. We will try to address most of your queries here or come back to you individually in case we run out of time. The presented talk would be for 40 to 45 minutes, followed by questions selected at random. I would now like to introduce you to our panelist for today's webinar, my colleague Mr. Fahid, Director, CSS Group. Fahid handles product management and business development for SYNC products in Americas and Europe. He has 16 years of industry experience designing and implementing communication solutions for the energy industry. His core area of expertise and interest is providing solutions for automatic fault collection and remote access systems for various utilities. He also has been involved in designing and implementing of various legacy as well as standard protocols in our SYNC gateways, including the IEC 61850, IEC 60870-5, SPA, C37.118, among others. Without any further ado, I would like to pass controls to Fahid, who will take it forward from here. Over to you, Fahid.
Yeah, thank you, Gautam. So good morning to all. Today in this session, I'll be dealing with securing medium voltage and high voltage substation with our secure gateway. We will be dealing with both SYNC3000 as well as SYNC2000 to secure the communication from the center to the substations. So this will cover certain standards and other features needed in SYNC3000 to secure the complete communications. So first, we move on to the threats and vulnerabilities which we face in the substation environment. First case is obstruction of operations. It can be because of safety failure or equipment failure that is caused by an attack. Then second, the data security being compromised by an unauthorized access. That is someone who was not supposed to access the data or an unauthorized modification of the data. Then availability based effects, that is malicious software attack, and in this case the complete machine or network resources can be made unavailable to intended users by permanently disrupting the services, like flooding machine with a continuous request, that is on the compromising the availability of the system. Then non-repudiation attacks, that is in this case comes when the system does not adopt controls to properly track and log user actions. So this attack can cause deletion of logs that has already took place, or addition of logs that does not took place. So these are some vulnerabilities that can be treated as a cyber security vulnerability within a substation environment. Now we move on to security standard coverage. In this case, we are focusing on three types of standard. One is standards on information security, that is highlighted by orange color, standards on power system, and industrial automation standards. So moving on to standard on the information system, the foremost standard is RFC 7252, which deals with a constrained application protocol, or in short we call it as a COAP. It is a web transfer protocol for lossy network, which is completely used mainly for the configuration purposes. The second standard is RFC 6960, or we call it as OCSP, which is Online Certificate Status Protocol. This is used to continuously check the status of the certificate, which is X509 based certificate, and validate whether the present certificate is proper and the access are permitted. So that is on the OCSP. Third standard, which is important, is EST, Enrollment over Secure Transport. This is used to exchange the certificate to various clients. This standard is used. Then GDOA, that is much more related to power system. This standard is group domain of interpretation, used to exchange the keys between the system, like ghost key and other things can be exchanged using GDOI standard. Then another is transport layer security, and the latest one is TLS v1.3, and this provides secure transport layer over the non-secured underlying layers, and there can be a tunnel established between a server and client applications. So these are standards related to the information system. And moving on to standards related to the power system, general cybersecurity requirements for power system automation, protection, and control is dealt in C37.240 standard, and we have a metering standard, including the DLMS and other related standard, dealt in IEC 62056. Then we have a complete NERC CIP governance, that is critical infrastructure protection scheme, and whatever applicable in detail for a substation intelligent electronic devices is treated under IEEE 1686, and the details of conformance is needed for the power systems is for a IED in a substation is given under 1686. Then next standard is 15118. This is for defining vehicle to grid communication, including charging and discharging of electrical vehicle is dealt in this standard. Then 62734 deals with wireless communication network and its communication profile, especially applicable to low rate wireless. Then another important standard that has come up is 61850 8-2. This provides a specific communication service mapping over XMPP, Extensible Message Presence Protocol. The complete 61850 models and abstract communication service interface getting mapped to XMPP interface is dealt in 8-2 standard. Then we have a general security standard for complete TC57 protocols, including 60870-5-6, 61850, 61970, that is EMS, and 968, that is DMS system, and its management is completely dealt in 62351. So that these are major standards that deal with support power system, security standards that deals with the power system. And we have an industrial automation standard, which is IEC 62443, which is dealing with procedure for implementing secure industrial automation and control system is dealt in the standard. So these are major standards that is covered under the security perimeters within a substation. Now moving on to NERC CIP standard. So NERC, that is North American Electric Reliability Corporation, has put forward critical infrastructure protection standard, which is applicable at multi-dimensional, like a physical security, personnel, what are the training required for person, what are the cyber assets identified, what are its management and control, what is the mechanism when there is a problem with the cyber security, there is a vulnerability detected, how to report the system, what are the recovery standard. Everything is dealt in the NERC critical infrastructure protection standard, and the standard to which we conform is version number 5, and the major thing that is applicable for the IED, that is substation environment devices, is electronic security perimeters SIP 005 version 5. So that is a standard which will be mostly dealing with our equipment security. 62351, this is again a TC57 defined standard, and there are multiple standards involving all the TC57, and the third one is profiles including all the TCP IP. So all the protocols which uses TCP IP need to follow this, and TLS and other things are mentioned under 62351-3. And 62351-4 is applicable to MMS and related payload. So MMS mapping for the 61850 and XMPP mapping for 61850 is dealt in this, plus ICCP standard also follows MMS. So that is also dealt in 62351-4 standard. Then 62351-5 is applicable to 60870-5 and its derivative, including the DNP3 secure authentication and other profiles, is dealt in under 62351-5 standard. 62351-6 standards deals with, in general, all the other 61850 parameters, communication details including goose and sample values, etc. is dealt here. Then 62351-11 deals with the energy management system and distribution management system and common information models. What are the securities related to that? That is dealt in 62351-11. Then object for network management, role-based access control, detail of defining the various roles, its access, everything is dealt in 62351-8. Key management is dealt in 62351-9, and GDOI is in turn referred in the standard. and the other logging and other concepts are dealt in 6235-14. Complete RBAC guidelines, then detecting a vulnerability based upon deep packet inspection, then security system general guidelines, different architectures for TC57, then security requirement for distributed energy resources, and other new standards are also dealt in 62351 variants in the standard. So this is overall 62351, which is completely applicable on any of the TC57 protocol. So now moving on to 1686. So as I mentioned earlier, SIP provides general guidelines on whatever applicable to an intelligent electronic devices, including all the electronic devices within a substation perimeters, is dealt in detail by IEEE 1686 standard. This covers access, operation, configuration, firmware revision, and data retrieval from any of the intelligent electronic devices, including the substation gateways, is dealt in this standard. So this is covers a basic conformance statement in which various parameters are described, and whether we comply with the same and with the comments, like whether there is any password defeat mechanism and other types are there. So need to comply, and with the comments we have to mention what are the things implemented, what are the things not implemented, and other details need to be given as a conformance to 1686 standard. Now moving on to security objectives for completely on the substation. So all the critical infrastructure need to be protected, and broad guidelines for the same is indicated in NERC CIP 5. And after that, a detailed security guidelines based upon the SIP for the complete intelligent electronic devices within substation is given under 1686. Then protocol, communication, and data security for complete protocol-oriented communication is given by 62351, including role-based access. So these are the three broad standards which covers all the security requirement, and our objective is first to manage this system. That is, first step of manage is to provide almost 100% availability of the system, and then centralize, manage authentication, authorization, and accounting. Authentication means validating your credentials like username, ID, password, and verifying that you are the right person who can enter into the system. This is by ensuring login form, different HTTP authentications, exchanging X509 certificate, and there can be custom methods also for verifying you are the right person to enter into the system. And after authentication, next step comes authorization. Decides if you have a sufficient or enough permission to access a resource or perform certain action. So access control URLs, access control list, secure objects and methods are used for authorization purpose, and whether you are authorized to perform selected actions. That is step second. And third step is accounting. Once you are authenticated, authorized, then whatever actions you perform need to be accounted, logged into detail for any further analysis of whatever happened in the system. So this comes under the manage. Then all the other things like any vulnerability, any other deviation need to be logged, all the actions, audit trail, everything need to be logged, and alarms and events need to be generated on any suspicious actions or any deviation, and this need to be continuously monitored to protect engineering data and live SCADA data against the intrusions man in the middle attacks and denial of service attack. All the things need to be protected. So 3 concepts: manage things, monitor the things, and completely protect the system by making use of all these monitoring capabilities. So in order to do the identity and access management for the substation, so this indicates a substation in which multiple devices are connected, and we have a SYNC2000 or 3000. 3000 will be used for high voltage substation, and 2000-M5 will be used for medium voltage substation. And you have a secure connectivity to the central device and access management system. We call it as a Kalki IO to manage your all the role-based access that can be performed onto the substation, multiple substations, and this complete configuration of different roles and roles are mapped to a group of roles, and this can be related to a user group, and multiple users can be created under a user group to allow you certain permission on certain things and block certain permission on other things. And this include a functionality based providing a role based access, or a location specific like a substation specific, region specific, or a device specific role based access can be performed from the central system. And all the certificate is put as X509 certificate, and that is transferred onto the end substation system to ensure that the communication between the systems are highly secured. And we also have a secure protocol tunnel channel between the control center and substation for monitoring the data in a secure manner. So this provides a view of the things. So you have a substation. In the substation, you can have a SYNC3000 and 2000 depending upon which substation you are dealing with, high voltage or medium voltage. And always custom devices can be connected to the SYNC devices. And if it is 61850, it is -3 is applicable on 61850 also, and you can monitor the data based upon that to SYNC devices. And all the local engineering and the remote engineering is through secure tunnel, TLS 1.2 tunnel, which we currently support, and that is and CoAP protocol is used for the engineering configuration, and this is tunneled over a TLS 1.2 secure channel, so it can be over from the remote system or a local system. And to do the complete identity and key management, including patch management, secure central security logging, role-based access, configuring different role-based access, key management, and cyber security requirements management, all this standard-driven management is done through Kalki IO, and there is a module of identity and device management in the Kalki IO, which provide a secure tunnel between the device and Kalki IO central application, and whatever we have configured as a RBAC access is taken into X509 file, and that is to be securely transferred to respective substation for ensuring that the proper authorized and authenticated actions are only performed on the devices. Then we have a secure HTTPS web HMI for monitoring the system from the operator system point of view. And we also have a secure tunnel with the DNP3 secure authentication protocol, that is with respects to 62351-5. So even selected actions, like some of the, for example, there can be multiple control centers, and from one control center there need to be certain parameter monitoring only is needed from certain control center, and from certain control center you need a monitoring as well as control that can be selectively accessed using a secure authentication, in whether it is in DNP3 or it is adaptation of 62351-3. for the DNP3 is secure authentication standard, and for 104 is 60870-5-7 is the standard, that is for the communicating with the control center through a secured, that is challenge response scenario. That is whenever you need a critical action to be performed, there need to be a challenge to a system, challenge for that action, and if that is allowed, then only that is permitted to go further on that. Then we have a detail of ports and services control, that is part of a firewall setting in SYNC3000 or 2000, and we also have a network monitoring facility through SNMP-v3, time synchronization of the system using NTP-v4, and also we have a secure file transfer protocol through a secure FTP channel. So these are complete digital substation which is accessed securely from the control station, and from the Kalki.io. It can be used for the identity and device management, sitting on the center, manage the corresponding substations with a detailed role-based access mechanism. Then after moving on to the overall system, we now shift our focus on the gateway related stuff. What are the detailed functionality that is available in the gateway, which ensures that there is a proper security in various aspects, so that access to a substation is completely secured, whether from a control center or a third party, any access to the system. So we have divided the complete security thing into 6 pillars of device security. So we are treating 6 important concepts to be incorporated in SYNC3000 as well as SYNC2000-M5. So these important pillars are secure device access. The device access from the center need to be detailed and secure, completely secure, and we provide it based upon a 2-factor authentication mechanism. Second pillar is communication ports and its control. So detailed firewall need to be implemented, allowing only mandatory ports to be open for the communication, disabling all the unwanted port, and different use case scenario need to be protected in principle of the security things, and there need to be firewall, detailed firewall setting for the same. Third point is completely encryption of communication link and data, the encryption of protocol level encryption for the data and the communication link. Fourth one is how to update firmware and configuration effectively and ensure that there is no malware put on to the device, which can make the device to perform unpredicted actions. So how that the same thing can be avoided by using a secure firmware transfer or secure configuration file transfer from the central system. Fifth major point is authenticating device access, how we perform a role-based access control And last point is, after doing all these things, what are the logging and alarm and event functionality available, which allow us to track completely what are the actions that has gone into the system, what are the security vulnerabilities that has happened, what are the alarm conditions that has come in. So these are 6 major pillars of the security. Now we will be going in detail on every aspect of this. So secure device access, that is, need to secure the complete access to the system. So we have multiple access. First is root level privilege, that is only allowed through an RS-232 debug port. In debug mode, that is a complete access to the system, so only allowed in a console access through RS-232 port and only in debug mode. Second user is system user, which is completely internal, and all binaries running in the system will be running with this privilege only, and it is internal. And third and fourth are most important access. So admin and application, we provided SSH, secure shell access for both admin and application. Application is also having discretionary access control for third-party application to be put onto the system. So that is the difference between admin and application. Both admin and application user, we have a two-factor authentication. So there is a login mechanism, plus we provide an OTP mechanism and a TOTP key, and corresponding OTP value is need to be entered to get into the system, to make sure that two-factor authentication is completed and a suitable permitted person is only entering into the system with the admin and application privileges. The next step is whenever there is a major security vulnerability with the existing system, is that we set a default password, and in the site customer forget to change this password at the site. So what we have provided for that is, whenever you connect to the system at first, it is mandatory to change the default password, reset the default password when we connect it to first time to the system. So any other action, if we need to perform, this reset of the password is mandatory, and this is mandated as per the CIP guidelines also. So this we implemented, which is in place. Then strong password enforcement as per CIP, that is combination of lowercase, uppercase alphabets, then numerical and special character with a minimum length is mandated, and enforce password rotation on every 15 months is also mandated. Then different configuration options are provided. When any user crosses maximum retry attempt, he enters into a configured lockout period, to which he will not be allowed to perform any action. In order to get out of this, either the admin privileged user need to either the user need to wait for the lockout duration period, or the admin user need to reset the TOTP or TOTP keys from the admin level, or reset account lockout so that the other person can re-enter. So these are the other action that can be performed to avoid a lockout condition which is there in the system. So we move on to details of this. So secure device access. First thing is the password need to be entered, and all root admin application, it is mandatory to enter the password, and EasyConnect must be used for assigning the password. and it will prompt the passwords, and it is mandatory to enter all this password to proceed further. Then once this is entered, TOTP keys will be displayed on the EC Connect, and this need to be copied and used with any third-party authenticator like a Google Auth to get the corresponding OTP key at any present time, and that can be entered for the SSH or SSH access. Then 8-character length password is mandated with 1 lowercase letter, 1 uppercase letter, 1 number, and 1 special character. And once that password everything is set, TOTP keys will be sent back, and this can be used for further to generate the OTPs. So this is a window showing the details of entry for the root password, admin password, and application password. Once this is set successfully, TOTP key will be displayed on the screen, and this will be used to generate the corresponding OTP at any point of time. Then as this is again how to change the TOTP trust key. So that is using the EC Connect, the login with the adequate privileges, and go into the security part. Then under the section TOTP keys, there is reset TOTP keys provision is there, which can be used to reset the admin and application TOTP keys. If there is system finds there is unauthorized access, first thing that can be done is reset the TOTP keys so that the earlier TOTP keys are no longer valid and nobody can have a SSH access onto the system. Then on the SSH account settings, so one of the key things is lockout duration that can be set. Then maximum retry for the lockout duration can be set, and if the failed attempt crosses this maximum retry, then this system will be the user cannot enter into the system for this lockout period, and the reset lockout can be performed by a admin user from the EC Connect software. So these are some of the settings on the SSH side to make sure that the system is highly secure. Then second pillar of the security is communication ports and control, nothing but firewall. So physical ports can be controlled using the firewall setup, and any logical ports can be controlled like TCP port, and everything can be controlled using EC Connect configuration utility. There is a default firewall policy which allows only mandatory, that is only the mandatory ports to be open, and any changes can be done by user. Any priority of the rules can be changed, and there can be a local network as well as a network reachable from the center. So there can be a network address translation policy can be there to transfer the packets from the center and transferring it to a local network. So that can also be configured with the policy in place. So this is showing the firewall setting in details. So you have to go to device settings, security, and firewall, and you can select block any of the Ethernet ports, or you can block any of the input, output, or forward any of the ports from one port to another. Block, draw, accept, and use a filter rule. These all the things can be permitted in the firewall setting. So detailed things are given in the firewall setting, which will allow you to completely control whatever the ports and other things that are permitted, whatever application ports that are permitted, all the things can be configured. Then third important thing is encrypting the communication and link and data. So for encrypting the setup, we use a TLS 1.2 tunnel, and for doing any configurations to the system, we are using a CoAP protocol, constrained application protocol for configuring traffic monitoring, data monitoring, that is SYNC-DB, database monitoring, web server, and facial data concentrator diagnostic. All these things we are using a CoAP protocol over TLS 1.2 tunnel. And TLS 1.2 tunnel is even connected with the other things like a web interface and other things. We are using the same tunnel itself. Then SNMP v3 is implemented for the network management, and NTP or SNTP v4 is used for the time synchronization of the system. Secure file transfer protocol is used for the file transfer, and SSH based connections are permitted for the admin and application user with the two-factor authentication. And if we prefer it, the customers to use the TLS tunnel itself, but if any customer is particular in having a VPN tunnel based SSL, that is also permitted, but there are security compromises for the same. So these are on the encrypting communication link and data. So we are again going back to the earlier diagram in which the encryption is detailed. So local engineering system and remote engineering system, it is done through TLS 1.2 tunnel and CoAP over that, and the further communication is done through the DNP3 secure authentication channel, and identity and device management is again done through TLS 1.2 tunnel, and HTTPS web HMI is used for monitoring the web based HMI things, including alarm events and SLDs. And there is SNMP v3, NTP v4, and SFTP to transfer files, network management, and synchronizing the system. So this is overview of secured communication link and data to the complete system. Now moving on to controlling the firmware and configuration. So this is fourth pillar, which should mandate that no malware is permitted in the system. It should block any malware that is put onto the system. For this, we sign the firmware completely, and this device only accepts the digitally signed files, and the firmware signing and its licensing is completely based upon the PKI based licensing system. And we have a phase-wise signing of the firmware in which the device has got multiple levels like development level, testing level, and final deployment level. And we have a separate signed firmware for a development environment, testing environment, and a deployment environment, and only the corresponding thing is permitted to be put on the corresponding stages of the devices. So that we call it as a phase-wise signing of the firmware, which we ensure that it is completely secured. Then we have a standard trust chain for firmware update, and other things customer can use their own trust chain, and project specific trust chain can be implemented for making the complete system trustworthy with specific to the server installations. So this is on the controlling firmware and configuration update, securely doing the same. And moving on to fifth important pillar, which is role-based access control. So this is done through the identity and access management system through Kalki IO, and fine-grained feature access control is permitted with this. In this, selected roles can be mapped. Selected actions can be mapped to the roles. Roles can be grouped, and there can be a user group, and under user group multiple users can be there, and the permission and its files are based upon X509 certificate based. And there are three different modes for the user. First mode is OCSP, which is Online Certificate Status Protocol, which requires a mandatory online connection with the central certificating system, in which every time it is checking for the validity of the certificate online, and if that is permitted, then only it will be allowed to further process the thing. Second mode is global, in which this certificate is preloaded onto all the clients, and this certificate will be valid until the expiry date of the certificate. This certificate will be valid. This certificate will be valid. That is global mode. Then third mode is attribute certificate mode, in which it will be put onto the system, and occasional, that is time-based check will be performed to validate this certificate. That is attribute certificate system, and this all the things are using X509 certificate. And DNP3 protocol, if we use DNP3, SAV5 will be used based upon 62351-5 for authentication of authorization of selected action, like controls, monitoring data, everything can be selected separately in the secure authentication. So protocol wise function can be further drilled down using this thing. Then sixth and last concept is security logging. So we mandate all the security logging of all the audit trail, all the packets and other stuffs will be logged, including the user access logs and other things. So only root user has got a privilege to modify or delete audit trail, and based upon the requirement of the system, maybe we can also make root user also not having a privilege to delete the files. And this is stored for 90 consecutive calendar days as per SIP standard, and any login, invalid login attempt, invalid firmware update, etc. Triggers a security alarm, and that can be monitored from the center. Then device logs, there can be multiple types of logs. System logs can be there, device access log, protocol communication log based upon protocol communication channel. Then application specific log like VPN, PPP dial-up logs can be there. Phaser data, if you are using it as a phaser data concentrator, phaser data concentrator logs are also available in the system to monitor the stuff and control the access based upon whatever is the deviation of action that took place. So these are some of the examples of the logs. I'm not going into the detail. Device logs, SYNC database monitoring, whatever is present in the database, you can monitor using SYNC monitor. Then this is the protocol based logs, like a protocol channel logs or packet diagnostic logs can be monitored. Then other improvements, we are working out on other improvement. Complete project file, that is configuration project file, can be encrypted using a user defined password, and 256-bit AES encryption can be used. then update the system packages like kernel file system as a bundle to the device, either from EasyConnect or Kalki.io. Then before and after update, major network settings are preserved so that this will not override the existing network setting. Then we also adopt a reliable file transfer mechanism. So even if it is a lossy network, it starts from the point from where this has stopped, and it can resume from there. Then we can have different shutdown functionality based upon the modules within substation data concentrator, like shutting down the switching function of SYNC3000 can be available. So this is overview of whatever we have discussed, complete architecture, a recap of complete architecture. So if you move on to the right hand side, you see the SYNC3000 or 2000 with all the functionalities, like engineering is done through a TLS tunnel. There is a two-factor authentication for logging into a system. There are detailed firewall setting for the ports and communication channels. There is a 62351-5 based communication authentication, and that is again adopting the DNP3 SAV5 and 60870.5-7. Then signed firmwares is only permitted. If other firmwares are put, it will be automatically rejected and an alarm will be thrown. Then TLS 1.2 tunnel will be used for any communication. Web server is using HTTPS, detailed event, alarm logging, access logs, everything is there. Operator station is using a TLS tunnel, and it is through HTTPS, and we comply with the NERC CIP 5 and IEEE 1686 guidelines. And central we have a identity manager, key manager, and it is based upon the X509 and public key infrastructure. And all the device engineering, we provide a pass-through channel for the device engineering. There is a detailed patch management mechanism. There is a secure application integration functionality, configuration management functionality is supported, detailed role-based access and its management is supported, security logging, and details on the anomaly detection. We are bringing up details of anomaly detection also onto the system. So this is complete recap of whatever we have discussed, whatever security features we have provided onto the system. From this is on the substation level, and this is on the central level, and we have a SCADA system also connected to the system, which is the securely communicating with the different substations. So this is the complete architecture. So this covers the details of all the stuff. So moving on to the questions. Okay, so one of the question is why you allow a complete access when you log in as a root user. That is one of the question. So the question I think is, if you see our 4 different logging category, for the root user we allow it complete logging onto the system. The thing is that it is only allowed when you connect it to the console port in the debug mode. So there is a need to connect directly to the device using a console port. So a person need to come near to the device and plug it to the device. So he is treated within the physical security perimeters of the system. So that is already covered, and entering onto that system, it is guaranteed that the personnel is proper and that validity check is already take place as per the SIP constraint. And once he is logging into the system and in the debug mode, in order to perform critical functions, we allow this access for the root user to have this access. Then another question that has come up is, how do you, can you elaborate on DNP3 SA concept, secure authentication concept? So, so what we are dealing is with the general role-based access onto the system. What are things permitted, what are things not permitted? But within, from a substation gateway to the control center, we may need to perform certain actions, like some of the from one control station, one person can only view data. One person need to send command and view data. One person need not perform anything. So that type of controlling is needed on a protocol level. So in order to make this happen, generalized thing from the role-based access no longer valid. It need to be done on a protocol scenario, on a protocol basis. This need to be done. So we provide it on a protocol level access. So that is done using a DNP3 secure authentication, in which whenever a user is performing any critical action, the corresponding server will ask for whether you are valid to perform this action. So he need to respond it with the validity credentials, saying that yes, I am valid, I am ensured to perform this action. So that is guaranteed in a secure authentication. This is an adaptation of 62351, and DNP3 has put this as a secure authentication standard, and for 104 they have put this as 60870-5-7 standard in the 60870 scenario. So that is on the DNP3 secure authentication. And different key exchange mechanism and 61850 authentications, 61850 parameters you support. Okay, so key exchange personally we don't support using the GDOI, but manual key exchange is what we perform. So GDOI presently we are not implemented, and so that is not implemented. We have to perform it manually presently from the central system, but it is over a TLS 1.2 tunnel itself. So that is one of the answers. So this covers almost all the answers. So if you have any further, all the questions, if you have any further questions, do mail us.
Sure,
And
sure.
thank you for attending this. Back to Gautam.
Yeah, Faid, thank you very much for the detailed and informative talk today. To the attendees, once again, thank you for taking time out from your schedule to attend this webinar. If you've got any additional questions, as mentioned by Fahid, please feel free to drop us an email at marketing@kalkitech.com, and we try to get back to you as soon as possible. We will also be sharing the recording of this webinar shortly with all the attendees. Well, that's it for today. Have a great day. Bye. Thank you all.
Thank you. Thank you. Bye. Have a great day.